and hello everyone, good evening to all, greetings to all. So in this video we are going to discuss about the important problem, that means some examples problem from primary constant from chapter 1, transmission lines and waveguide and RF waveguide structure. Okay my dears, so we go for discussion. So what are the important parameters they given? So from the given data at 8 megahertz of characteristics impedance of a transistor line is 40 minus J2 and the propagation constant is 0.01 plus J 0.18 per meter. Find the primary constant. So what is the given data? Given data, the frequency is given. Given data, frequency is given. F equal to 8 into 10 to the power of 6, that means megahertz. 8 into 10 to the power of 6 hertz. The characteristics impedance, that means Z0 equal to they given with the polar format 40 minus J2 ohms per kilometer. In rectangular format they given Z0. Then under the propagation constant gamma equal to 0.01 plus J 0.18 per meter ohms per meter. So propagation constant also they given with rectangular form and the frequency also given. But our aim is to find primary constant. To find the primary constant R, L, C and G. So these are the very important parameters we need to solve. So how you are possible to get these important parameters? So already we know that our formula for omega. So already we know that formula for omega 2 pi and f. So f is already given. So 2 into pi into f, 8 megahertz already given. So 8 into 10 to the power of 6. Finally, you may get omega equal to 50.21 10 to the power of 6. So by using this omega, we are possible to get that means R value and L value and C value. So Z0 equal to already given 40 minus J2. So already we know that this is belongs to rectangular form. So we need to convert with the polar form. By help of calculator. So in the polar form 40 angle of minus 2.86. So this is the polar format for Z. 40 minus 2.86 polar format. The same thing in the gamma value also 0.01 plus J 0.18. So this is belongs to rectangular form. The same thing we are going to change with the polar form 0.018. The angle of 86.82 degree. 86.82 degree for 82.6 82 degree. Then by using this value, so the finally propagation constant in polar form is 0.18 into 86.82 degree. So already we know that this is the structure belongs to R plus J omega L. From this R value is to identified. R value is R plus J omega L. So what is the value for R? R plus J omega L equal to, so 40 minus J2 R0 into Z0. 40 minus J2 into 0.018 plus J 0.01. So just a minute. Actually here the value belongs to 0.01. So we have to multiply with the simplification concept with the direct multiplication 40 to 0.01 and real term to real term, imaginary term to imaginary term. So how much possible to get? The final value of possibility is, after multiplication of these two value, the final value of possibility is 0.4. Multiplication of 40 into 0.01, we may get 0.4 plus j into 7.2 minus j into 0.02 minus j square into 0.036. So j and j into j square. So you have to first you will take this two value multiplied. After this two value possible to get multiply. Finally, for simplified this value 0.4 plus j into 7.18 plus 0.36. Instead of this j squared minus 1, already minus is there. So finally we put plus 1. So finally r plus j omega L equal to 0.76 plus j into 7.18. So what is the value for r from this equation? R equal to 0.76 ohms per kilometer. So this is the value of r. This is the value of r. R equal to 0.76 ohms per kilometer. Then what is the value of omega L? So already we know that omega already we defined. So omega L equal to 7.18. So 7.18 parameters. From this omega L 7.18, from this easy to calculate L value 18 over omega already we know that 50.24, 7.18, 50.24 into 10 to the power of 6. So finally 0.1429 into 10 to the power of minus 6 entry per meter. So finally L value is 0.1429 into 10 to the power of minus 9 entry per meter. So this is the value from inductance. So already we find resistor and also inductance. So remaining parameters we need to solve. Remaining parameters we need to solve. So by using the admittance formula, y equal to g plus j omega c equal to propagation constant gamma by z naught. So g plus j omega c equal to 0.18, the angle of 86 degree to 82 degree polar format, and 40 with the angle of minus 2.86. So finally cancel this two value, we may get 4.5 into 10 to the power of minus 3 and minus this two value 88, or finally 80 minus this two value 86.82 minus of minus 2.86. Finally we may get 89.06 in angle. So this is also belongs to polar form. So we need to convert this polar form into rectangular form. We may get a direct G value. So in the rectangular form 7.38 into 10 to the power of minus 4 plus j into 449.10 to the power of minus 4. That means if you multiply this value 4.44 by using the calculator, you may get a polar form to rectangular form. This is belongs to rectangular form by help of the calculator. So 4.5 converted into 7.38 with the help of angle, with the help of alpha value, with the tan angle 449 to the power of minus 4. So from this easy to write G value equal to 7.38 into 10 to the power of minus 4 mu per meter kilometer. This is the value for G. Then J omega C. J omega C equal to, we need to compare this J omega C, the value of 449 into 10 to the power of minus 4. So already we know that C equal to 449 into 9 10 to the power of minus 4 by omega value is 50.24 10 to the power of plus 6. 50.24 into the power of plus 6. So already we know that omega value, omega equal to 50.24 10 to the power of 6. By simplify these two value, finally we may get C equal to 8.95 into 10 to the power of minus 10 farad per kilometer. Is the value for capacitor. Nanofarad means we have to consider 0.895 10 to the power of minus 9, that means nanofarad per meter. So this is the value for C. So now already we know that R value, so we have to write R value, L value and G value and C value. C value is 0.895 nanofarad per meter. G value is 7.38 10 to the power of minus 94 mu per kilometer. So then L value is 0.1429 microhenry per meter, and R value is 0.76 ohms per meter. So these are the very important parameters we solved. We took from primary constant from the given data. So these all are the belongs to primary constant R, L, G and C. Thank you my dear students. We will see in the next updating videos with the suitable problems with the help of secondary constants and how to find secondary constant, that we will discuss in the next class. See you again.